Good morning, everybody. My name is George Lennis. I'm with the Eberspaecher Climate Control Systems. Thank you all for joining the webinar today. So this is the agenda for the next 60 to 90 minutes. We are going to talk about the system itself that includes the Hydronic D5 heaters. We will review the different configurations, the databook codes, and we will discuss the differences between the first generation and the third generation, the specifications of each unit, the different parts and operation. Furthermore, we will also talk about the heater fault codes, the format for the fault codes, the error memory capacity in the ECU, the storage of additional data associated with the fault codes, the ECU lockout functions, and also very importantly, how to unlock the ECU or the heater by clearing the fault codes. When it comes to diagnostics, we will also review the different diagnostic tools that could be used with these heaters. We will talk about how to create the reports, how to go about testing components, and also how to do a functional test of the operation of the heater. And then finally, we will also review the service recommendations and also the warranty coverage limits, the policy and claim submission requirements. Here is the overview of the HVAC system on the Freightliner trucks. And as you can see, they are available in two different configurations based upon the location of the condenser. So if it's a center-mounted condenser, then the databook code for that configuration will be 689129. And if it's a left-mounted, then the current databook code is 689128. So this is a dual parked HVAC system. This is the new name, I would say, last couple of years that they've been using. But in the past, this system was also referred to as the Park Smart system or the BPHS system. They initially rolled out this system way back in 2007. As far as the heater unit that's used along with this system, we have the Hydronic D5 ST heater. This is our first generation heater. This is what was being used until about a year ago, I would say. And then now we have the newest third generation Hydronic HS3 D5E CS heater. This is our latest, the newest generation of the Hydronic heaters. So both of these heaters are used in these systems. So the current one is the third generation. The system also uses a common controller with the park button, which will basically allow you to set the temperatures and then also start the fan, and you can adjust the speed of the fan accordingly. Let's move on to the next slide. So where is the heater mounted? It is mounted under the floor. We have a mounting bracket attached to the bottom of the floor, and the heater that is lying sideways, it's secured to the bracket with a single bolt that passes through the heater. You can see all of the other parts that's connected to the heater. We have a flexible exhaust pipe that goes all the way to the back of the truck. We have a short plastic elbow that serves as a combustion air intake hose. We have the fuel lines that is coming from the fuel pump all to the heater and connects to the heater. We also have our coolant lines. When the heater is in operation, the hot coolant is initially pushed into the auxiliary heater core, so the driver can, stay warm, and then it's cycled through that core and then back to the engines, and then from the engine it returns back to the heater. So it's a single loop in series with the coolant loop on the truck side. It's a very simple system. The driver can switch on the unit by pressing the park button and calling for heat. And from that point onwards, the ECU or the control unit of the heater takes charge and begins the operation of the heater. What you're seeing in this slide is the mounting location and the orientation of the heater as it pertains to the first generation heater, which is a Hydronic D5SC heater. In a very similar way, we have now the newest heater that is also mounted under the floor, as you can see in the next slide. So this is the third generation Hydronic S3 heater. It is also mounted under the floor, but unlike the previous generation where it was mounted on one side, you can see it's mounted vertically. And you can see the configuration over here. It's mounted vertically. And because this is a newer generation of the heater, it also has an externally mounted coolant pump that is attached to the bracket that's holding the heater. And then, of course, we also have the fuel pump that would be mounted on top of the fuel tanks, just like with the first generation heaters. So configuration, the orientation is slightly different when it comes to the third generation heater. But as far as connection to the truck, it's still the same. So you have the output of the heater being connected to the auxiliary heater core. From there, it goes to the engine and then circulates back to the heater. So now let's talk about the specifications of both the first generation heater and the third generation Hydronic heaters. As you can see, the name is common. Hydronic applies to both first and third generation, but you can see the description is slightly varied. The first generation was simply described as a Hydronic D5SC heater. The D in the description stands for the type of fuel that the heater uses. So obviously in both cases, you can see the letter D is used for diesel. Number 5 is the output of the heater, the maximum output. So that reflects the maximum output as shown in the table. 5 kilowatt, which is about 17,000 BTU. What follows next is an abbreviation for describing the assembly itself. So this is a standard compact heater, and it's described as such because the coolant pump is part of the entire heater assembly. So let's say if you had to service the coolant pump, you had to clean out the coolant pump, then you would have to pull out the whole unit and then tear it down and then service the pump, for example. Whereas in case of the Hydronic S3, the nomenclature is slightly longer. It says Hydronic S3. S is defining the size of the heater. So we have the Hydronic available in 3 different sizes, the small, the medium, and the large. So this falls into the small category. 3 is indicating the generation of the heater. So this is the third generation. That's why the number 3 is used. D, as I mentioned, is the type of fuel. 5 is the maximum output of the heater. And the letter E stands for economy. It's also followed by 2 letters, and this describes basically the protocol that's used by the heater for communication. So C stands for CAN bus, and the S stands for S plus, or the analog signal, 12-volt signal that could be used to activate the heater. So that's the description of the heater. So now let's take a look at the specifications. So as we know, the maximum output between both the first generation and the third generation still remains exactly the same, no change whatsoever. It's still 5 kilowatt or 17,000 BTU. The minimum output, however, has been tweaked. So you can see initially in the first generation, we had a minimum of 2.4 kilowatt. That's been dropped to 1.3. And the reason to do that is to extend the running time of the heater without it having to restart. As you know, the most common failure point is usually when the unit tries to start and it's not able to start and it fails. So to minimize the chances or the risk of such failures, they have extended the operational range in terms of the maximum BTU, minimum and maximum BTU. So thereby, the heater will have to make fewer restart attempts during the whole operation of the heater. The heater will operate between this range, but when the temperature of the coolant exceeds a certain threshold, it will switch off automatically and then automatically restart again. This is the routine operation of both the first generation and the third generation heaters, excuse me. But in case of the third generation, the minimum output has been lowered so that the amount of times that the heater will have to switch off and then restart is basically less as compared to the previous generation. Now, as far as controlling the heat output, when you switch on the heater, it will always begin operating at 5 kilowatt or 17,000 BTU. But as the temperature of the coolant starts to rise, then the heater will switch to a lower output. In case of the first generation, there were only two heating stages defined, so it could only operate in those two heating stages. The first one was defined as the high heat output, which is 17,000 BTU or 5 kilowatt, and the next stage was the 2.4 kilowatt stage. In case of the Hydronic third generation, the S3 heater, it is stageless. It's more like a variable output. So there will be small incremental steps, and the output will be reduced gradually till it reaches the lowest point. This allows for a much better optimum control of the optimum temperature of the coolant, much more efficient operation of the heater. From a dimensional point of view, you can see they're very close. Not much of a big difference. Of course, we do have the coolant pump attached separately to the unit. It could be relocated anywhere, but in case of the PockSmart system, they have it along with the heater on the same mounting bracket. And then, of course, we have the fuel pump also mounted separately. As I mentioned before, the communication protocol, before we had, on the first generation, we had the LIN communication for diagnostics, that is to read fault codes. And then the S Plus, which I mentioned earlier, is just a basic 12-volt analog signal that was used to activate the heater. We have carried forward that same protocol to the newest generation also. So the S Plus protocol still exists, but we also have now a new CAN bus based protocol. Now, as of now, the Freightliner trucks don't use the CAN bus protocol to activate the heater. The feature is available, but they haven't utilized it yet. They're working on it, and based on what I've been told, we can expect something maybe in the next 2 to 3 years, where you could have a full integration of the heater on the truck side, and that means you would not have to have a separate diagnostic tool, and you would not have, would not need a separate controller, etc. Everything will be built into the truck. So two protocol exist. So in the current configuration, yes, the heater is still switched over the 12-volt signal that will originate from your PockSmart system controller. And for diagnostic purposes, the communication between the heater and the diagnostic tool will be over CAN bus. Now, one of the most significant changes in the heater is the fact that now we have a brushless motor, and previously we had a brushed motor. So obviously the service life was estimated to be about 3,000 hours on the first generation. And in case of the third generation, now we have almost 5,000 hours estimated service life, so almost double. Let's move on to the next slide here. Just going to quickly check for any last minute participants who may be waiting in the lobby. So just give me a second, guys. I don't see anybody. So yeah, we have 13 people logged in. And I'm hoping there are more with each participant. Anyways, so this slide, we are going to talk about the parts, and the way we are looking at the parts is basically I've arranged them on either side. One is the older unit and the newer unit, so the first generation and the third generation. So as I mentioned, this is the blower motor, which is a brushed motor with an estimated service life of 3,000 hours. Whereas now the newer generation, it's a brushless motor, estimated service life of 5,000 hours. And a couple of things, this unit directly connects to the PCB board on that ECU of the heater. Whereas over here we have the harness and terminal pins that will pin into the connector, and the connector is plugged into the ECU. So this is more direct, whereas this is indirect. When you have too many connections, of course, the chances of failure always will increase because of a loose contact or a badly crimped terminal, etc. All of that is avoided by using a direct contact to the PCB board. Having said that, this unit also has a much higher protection rating against dust and dirt and debris, but that's only the case if the seal is maintained. So at any point in time, if the heater is being torn apart for service repairs, whatever, then it is expected that the cover on the motor is always replaced because that's the part that seals, forms a perfect seal between the motor assembly and the ECU. So that seal will be compromised once you separate it apart. So every time you pull it apart and then reassemble it, you have to put in a new cover. Now, the whole purpose of tearing down a heater has to be first diagnosed correctly. You do not tear apart a heater just because you think something may be wrong. You will always do the diagnostics. We are going to do a brief demo on the diagnostics later on in the webinar. And based on your diagnostic results, the fault codes, etc., once you have verified that yes, you have a component that has failed, only then will you proceed with the teardown of the heater. And of course, when you do that, you always will have a spare part available. So for example, if you want to replace a fan assembly, or if you have to replace a sensor assembly, or if you have to replace the glow pin assembly, each of those parts will contain the cover for the motor. It's included in the scope of supply. That means anytime you tear apart the heater to replace any of those parts, you'll also replace the cover for the motor. One of the things I did not mention as we began the webinar, I mean, feel free to ask questions. Like I said, I've left the microphones open, so if you have questions, you may ask, or you could text in the chat. I will try and review them as they come in, or at least towards the end of the training, we could review all the questions. So feel free to ask questions as we go along with this training webinar. All right, let's talk about more parts. So as we can see, we are now talking about the sensors. And in particular, we are talking about the control sensor and the overheat sensor. That's what they were named as for the first generation heater. And you can see the sensor assembly depicted here on the slide. So it's actually two sensors. We have our control sensor, and then we have the overheat sensor. The color of the cables that's attached to each of these sensors will be different. So the one that's attached to the overheat sensor is colored red, whereas the cable that's attached to the control sensor is colored blue. They are part of one single assembly. That means if either one of these sensors go bad, you have to replace this entire assembly. You can also see that these sensors have O-rings around them, and these O-rings are supposed to be replaced each time you tear apart a heater and rebuild it. These O-rings are available as spare parts on its own. So you can see how the sensors are seated. So you have your control sensor seated right there. And then on the opposite side, you have the overheat sensor. And you can see this spring clamp basically is firmly holding the two sensors in place. For the Hydronic third generation heater, very similar concept. You do have the two sensors, as you can see here, the overheat sensor and the control sensor, but in the documentation they are not referred to as such. They are in fact referred to as the inlet sensor and the outlet sensor. So when it comes to the third generation, the terminology or the description slightly changes. Even though the description, the verbiage changes, the function does not. So the sensor that is attached to the red harness is still measuring overheat, whereas the sensor that's attached to the blue part of the harness is the one that actually is monitoring the temperature of the coolant, and based on which your heater operation is then decided. Another thing to note is that these two sensors are not on its own. It's part of a much larger subassembly. So this entire thing that I'm circling is called as the lead harness assembly. It has several other sensors and ground connections, etc. This is how you will receive it if you order it as a spare part. So it saves you the bother of pinning these sensors into the connector. It all comes pre-assembled for you. So once again, before you tear down a heater, you have to first check whether the sensors are really defective. You can visually inspect them. You can test the resistances. To test the resistance, you can use the connector. All you have to do is disconnect the connector from the ECU, and you will see in the next later slides that there is a small panel on that ECU assembly that can be removed and will give you access to the connector. So you don't have to tear the whole unit apart initially. All you have to do is pull the panel apart, and then once you have that panel off, you can unplug the connector and then probe the appropriate pins to check the resistance for any of these sensors that belong to this entire assembly. All right, let's move on to the next slide here. So here we can see the next sensor, which is again part of the whole lead harness assembly. It's called as the flame sensor. And as you may have guessed, the flame sensor is what detects the flame. And when is the flame detected? The flame is detected when the heater tries to successfully start. And this detection is done by measuring the temperature of the hot exhaust gas when the fuel is ignited and begins to burn. As you know, the exhaust will leave from the exhaust port, which obviously will have an exhaust tube that's connected to it. And as you can see, the flame sensor is seated right directly in its path. And this applies to both. You can see the flame sensor on the older heater. It's basically sitting on the fan assembly, as you can see. So that's the flame sensor that I'm pointing to. So this is a flame sensor. And this opening that you see below that is where the exhaust gas will have to flow before it exits the heater through the exhaust port. So the whole idea is to measure the temperature of the exhaust gas, and based on the temperature of the exhaust gas, the ECU is able to detect whether the fuel has successfully ignited or not. If you look at the newer generation, yes, it's still in the exhaust port, but the difference between the older generation and the newer generation is the location of the heat exchanger and the coolant jacket. So you have coolant circulating around the heat exchanger, but then that entire part of the heater is kind of separated from the sensor itself. So it doesn't kind of overlap the sensor. Whereas in case of the first generation heater, the heat exchanger and the coolant jacket was overlapping the sensor. So what would happen? Some cases you'd have very cold coolant that would influence the temperature being measured by the flame sensor, and that could lead to a delayed start. That is now avoided with the help of the redesign, where the sensor is no longer overlapped by the heat exchanger and the coolant jacket, and so it doesn't come under the influence of cold coolant that may be in that coolant jacket in the heater. Give me a second. I'm just going to just quickly look for any questions. If someone has posted any questions, okay. I don't see any questions, so we can proceed further with our presentation. So here is the next part. That is the glow pin. It's a very important part. Both the first generation and the third generation have glow pins because obviously they have to ignite the fuel. These glow pins will be initially preheated for at least about 40 seconds approximately before the fuel supply is activated. This allows for the glow pin to be at the right temperature so that when the fuel arrives, it can be ignited quickly. So over here on the first generation, you can see the location of the glow pin. The glow pin is fitted into this fitting, and you can see another picture below it that shows the fitting, the fuel fitting. So your fuel is basically supplied through these lines into the fitting, and your glow pin is seated inside that fitting. Now, also inside that fitting is what we call as a glow pin screen. This glow pin screen does the job of breaking down that liquid fuel into vapor and basically atomizes it. So the atomization is important because that way it can mix with the air that's being pushed into the fitting by the combustion fan, and then it creates that fuel air mixture that can be ignited by the glow pin. Over a period of time in service, these screens can build up carbon, and this again depends on the nature of the operation of the heater, the way the unit is switched on and off, etc., the quality of the fuel, the type of additives that may be used in your fuel system on the truck side, etc. So all of that can influence buildup of carbon. Carbon accumulation does happen, but the degree at which it happens, how severe it becomes, it depends all on different factors, like I mentioned, the quality of the fuel, the additives, the switching on and off of the heater, the restriction of combustion air intake, etc. All that will play a part. Now, when that carbon buildup does occur, then obviously it's going to interfere with the atomization process. So what we would recommend is, in case if you have a unit that's constantly failing to start and doesn't seem to want to start, seems to smoke a lot, in that case, of course, you'll have to tear the unit apart, and then one of the key parts that you would end up replacing would be this glow pin screen. It's a service part. When you order this part, you will also get these two O-rings along with it in the kit. And the whole point is to replace these two O-rings on the fitting itself, so that when you press the fitting down onto that bracket of the fan assembly, you don't have any fuel leaks. If you don't utilize these two O-rings, then should not be surprised to see fuel leaking from your exhaust. So always remember to replace those two O-rings. Um, if you are tearing down a heater, let's say, to replace a glow pin or a sensor or any other part, I would definitely recommend that you should also replace the glow pin screen at that point in time rather than having to come back again at a later date to do it. So this is all for the first generation hydronic heater. That's how it is. Now, if you look at the third generation, it does have a glow pin. And by the way, the glow pin, the tip of the glow pin, in both cases, it's made of ceramic, so it's a tough material, and it's a long-lasting material. In fact, they have enhanced it on the third generation so that the minimum duty cycles you can get from that glow pin is it's rated for about 100,000 activation cycles. So it's a very long-lasting glow pin, provided you don't break it while removing it or cause damage to it. Now, in case of the third generation, they also modified the design. That means before you had to unscrew the glow pin from the fitting in order to remove it. And of course, before you unscrew it, you have to disconnect it from your connector. Over here, yes, you will still have to disconnect it from the connector, but then you can simply pull the glow pin off without having to unscrew it. It is just placed into position, and these grommets that you see on the glow pin assembly is what locates the glow pin in the right position. So which means you don't have to use any special wrenches, etc. Also, when it comes to assembling it, you don't have to worry about, tightening torque, etc. So it's easier to work with, if you may. Once again, glow pins are they are built solid. That means chances of failure is very, very low. So unless you have a justifiable reason, or through the activation of fault codes that yes, you have a bad glow pin, you would not have to replace it. You'll have to unpin the glow pins from the lead harness assembly. basically which has the two sensors, the inlet and the outlet sensor, and also the flame sensor and the ground cable for the ECU. All of this is pre-assembled into the connector. So all you would have to do is unpin it, and then if you're replacing it, of course, you will push the new glow pin back into the connector. Here we have the burner tube or the flame tube assembly. So this is basically where the fuel air mixture is ignited, and this is where the combustion process happens. The difference between the two burner tubes or the flame tube assemblies, the fact that on the newer generation, and this is made of stainless steel sheet metal type build, whereas this was more like an investment casting. Of course, because it was an investment casting type part, the pricing on this part was much higher. So to reduce the cost of the overall unit, they started using the stainless steel sheet metal. But you will see that they haven't compromised on the quality. These assemblies are put together by laser welding, so it's much more precise, much more refined. There are no spatter marks, etc. And this is built to last. On this burner tube assembly, at the back, you have an evaporative mat. You can see a small little opening that kind of exposes the mat on the tail end of it. And that mat is also protected in the front with this sieve kind of material. And then the point is that the fuel will flow into the mat, gets absorbed into the mat, and then when the combustion in a fan pushes air into this burner tube assembly, you have vaporized fuel basically being pushed in front of the mat, right in the path of the preheated glow pin. And then around the tube, you have all these holes, multiple holes that are punched to allow for combustion air to basically mix with that vaporized fuel, and then it can be ignited. So based on this new design of an evaporative mat, you can see there is no need for a glow pin screen that I described in the previous slide. So that's one less service part that you have to worry about in the newer generation heater. Also, because this is a much larger opening, it's not more like a bottleneck like in the previous design. The chances of this heater, failing because of a small speck of carbon is highly unlikely. So the reliability factor of this heater goes way up. We have the heat exchanger that basically allows for transfer of heat to the coolant that would be circulating around it. Of course, you have the coolant pump that does the job of drawing the coolant from the truck circuit and pushing it into the heater over the heat exchangers and then back into the truck side. The newer design allows for a much better path or flow of coolant with the minimum amount of restriction. Also, the surface area is enhanced so as to allow for a better transfer of heat. And also the fact that I mentioned before that the heat exchanger and the coolant or the water jacket is kind of separated from the colder parts of the heater. For example, the ECU and the fan assembly, and the whole purpose of isolating those cold parts is to enhance the service life of the entire unit. We also have the fuel pump, as you know. These are basically what supplies fuel to the heater. This is what the pump would look like if you were to order a replacement part. Freightliner does not use the suction side fitting. So this small part that you see over here, this is not used by Freightliner. Freightliner instead uses their own proprietary fitting that is mounted on top of the tank, and that fitting also has a standpipe that drops into the tank. Now, if you run into issues where the standpipe has broken and fallen into the tank and now your heater doesn't start, if you run into those kind of issues, you should inform us, give us the VIN number, You could also contact your local dealer, let them know so that between us we can inform the factory, and then they can take corrective action. The pump itself, both on the first generation and the third generation, it's a pulse pump. So the ECU will send 12-volt pulses to the pump. And based on the pulses, the piston in the pump is basically pulled back and released. And so that moving action of the piston back and forth is what allows for fuel to be drawn into the pump and pushed towards the heater. The ECU regulates the flow of fuel just by increasing or decreasing the frequency of the pump. The newer pumps are redesigned. The material has been changed. The dimensions have changed. Also, the operation of the pump is slightly different in the sense that the piston on its return stroke is braked electronically. And this way, what happens is it doesn't make a loud noise. Now, in our trucking market, we are not very particular about that noise. But when you use the same heater, let's say in much um, other applications like the RV application, for example, or passenger cars, for example, then the noise definitely plays an important role. Customers don't like too much of a noise, so that's why this redesign was done. So because of the redesign, the newer pumps are much more quieter as compared to the older fuel pump. So if you have been used to hearing the fuel pump ticking away, and now on a newer truck with a newer heater, if you don't hear the pump, please don't automatically assume that the fuel pump has gone bad. Place your hands on the pump while it's operating, and you should still be able to feel the pulse, the pulsing of the pump. That will tell you whether your pump is operational or not. Another small feature, which is not really important, is the location of the electrical connector. So on the newer pumps, the electrical connector, first of all, it's much more smaller in size, and it's on the suction side of the pump. That means this is the pump, this is the side of the pump that draws the fuel from the fuel tank. Whereas on the older generation, we have the electrical connector on the pressure side of the pump. So this is the side that connects to the heater. In case of both the fuel pumps, we have a preferred mounting angle between 15 to 35 degrees. As I mentioned, Freightliner uses their own proprietary fitting, and on the third generation heaters, they have a fitting which is 35 degrees, whereas on the first generation, instead of 35 degrees, they chose to go with the 45-degree fitting, probably because it's more commonly available. It's not a special part. And even if you were to increase the angle to 45, as per the guidelines, it is acceptable. It's not preferable, but it's acceptable. And then we have the ECU. So you can see the older heater ECU on one side. It's completely sealed. There is a potting material on the PCB board, so nothing is visible. You're not able. It's non-repairable part. If you have a bad ECU, the only option is to replace it. The chances of an ECU going bad is very, very slim. Please do not start off your diagnostics and repairs by replacing an ECU, because that's not how it should be done. As I mentioned, you have to go through the diagnostic process, and if you do have an ECU fault code, of course, you should replace the ECU. I'm not suggesting that the ECU never fails. There could be times when the ECU may fail, but then you have to make sure that it is an ECU failure. The ECUs are the most expensive part of the whole heater assembly. What you see on the right-hand side is the ECU for the generation hydronic heater. It's more of plastic. As you can see, the housing itself is full of plastic. The PCB board is at the bottom, and if you look at the assembly here, it shows several tabs around the bottom part of the assembly. The intent is not for you to remove it or tear it down. There's no purpose in doing that, because if you have a bad ECU, when you reorder the ECU, you'll get the entire sub-assembly as you see in this picture as a spare part. That includes the side panel that I referred to earlier. And if you remove the side panel, you have access to the connector. And it also includes the two mounting screws. So let me take a look at our chat just to make sure no one has posted any questions, and I don't see any. So we're going to go ahead and with our presentation here. The coolant pump itself, these are magnetic pumps. So if you have contamination in the coolant, of course, they'll all get deposited in the pump itself, causing it to slow down. If your pump slows down, then of course the flow of coolant running through the heater is affected, and that basically will cause overheating issues, you know, the heater switching off very quickly, etc. So if you do run into such kind of an issue, the first generation coolant pumps are serviceable. As you can see, you can disconnect the whole pump assembly from the housing itself, and then you can further tear apart the pump assembly to clean it, put it all back together. When you reassemble it, when you put the pump assembly back to the housing, the only part that you will require to replace would be this O-ring, and this O-ring is available as a spare part. Unfortunately, on the coolant pump on the Hydronic S3, these are non-serviceable in the sense that you don't have any replacement part, especially the O-ring is not available as a replacement part. So in case if you have a bad pump, which is highly unlikely, then you will have to replace the entire pump. These pumps are regulated as compared to the first generation. So first generation, the pump would run at a constant speed, whereas in case of the third generation hydronic heaters, these coolant pumps can be regulated. And by default, it is set to regulation. This regulation feature can be turned off by the customer. So if Freightliner chooses to have a non-regulated version, all they have to do is switch it off or and in the ECU programming, and then that way the pump will run at a constant speed. Because it's a regulated coolant pump, it'll have 3 wires on the electrical connector. So here we can see the connection for the third generation heater. The first generation has a single connector, whereas over here we have 3 separate connectors. We have the main power supply connector, which is a 2-pin connection. And just like in the first generation heater, the main power to the heater should come as far as possible directly from your batteries, and that's how it is set up on the Freightliner side. And you must make sure that this is the case, because there have been some cases where the wiring has been done the wrong way and the heater loses power. And if the heater loses power during operation, it can shorten the life of the fan assembly because it damages the fan assembly each time the heater shuts down without going through a cool down cycle. On the newer generation, we have the signal connector. It's a 6-pin connection. As you can see, pins 1 and 6 are for the fuel pump. Pin number 2 is the input signal that comes from the Park Smart System controller. So pin number 2 is where you will read 12 volts when the Park button is pushed. Pins 3 and 5 are for the CAN bus, but as I mentioned, this is currently not used on the truck side, so it is there but not used. Pins 3 and 5 will, however, be used when we connect to a diagnostic tool. Then that's when these 2 channels will be used. And then, of course, we have number 4, which is an output, which again, this is not utilized on the Freightliner application. And then we have the 3-pin coolant pump connection, as I'd mentioned in the previous slide. So let's take a quick review of how the heater operates, and there is a lot of similarities between the first generation and the third generation. So anytime you switch on a heater, it will always do what's called as a systems check, where it'll check all the internal parts of the heater. So as you can see, all of these parts would be tested. And if any of these parts would happen to fail during the test, then the heater operation would be stopped immediately. The heater will not proceed further. So this always happens, and if it does happen, and you have a defective part that prevents the heater from operating, then the active fault code would be stored in the ECU. And once you use your diagnostic tools, you can read those codes, and then that way you'll be able to tell which of these components failed, thereby causing the heater not to start. Once the systems check is done, now it moves on to the next phase, startup and ignition. And this is also the same for the third generation. So here the coolant pump will be activated, and then it remains activated till the end, when finally the heater is switched off. The glow pin begins to preheat, as I mentioned earlier. And then around the same time, the fan also begins to operate, because we would want air around the glow pin as it's preheating, otherwise it'll burn the glow pin. So the fan starts at a low speed initially and quickly ramps up. And then about 42 seconds later, that's when the fuel pump is activated. That's when the fuel starts arriving in that glow pin chamber. It basically soaks into that glow pin screen, evaporates, and then mixes with the air, and that air fuel mixture is then ignited. Once it's ignited, the exhaust gas will be pushed out through the exhaust port, and the flame sensor that is sitting right in its path will measure the temperature. And when the ECU sees that temperature is quickly rising, it knows a flame has been detected, and then it will switch off the glow pin. Now, for that flame detection process, the ECU will allow 90 seconds in each start attempt from the time the fuel pump starts. So 90 seconds is referred to as safety time. Now, what happens if within 90 seconds, let's say, the fuel did not ignite and therefore the temperature did not go up on the flame sensor? So what then? Then the ECU has programmed instructions that calls for the heater to make a repeat start automatically. So if the first start attempt fails, the heater automatically makes a repeat start attempt, and this is true for both the first generation and the third generation heaters. Now, if both the attempts were to fail, then guess what? The heater switches off with an active fault code. All right. So that is your startup and ignition process. Now, once it starts up, the flame is burning independently. Your coolant is getting warmed up. The temperature sensor or the inlet sensor is monitoring the temperature, and at about 176 degrees. Now, this is for the first generation heater. This could be slightly different on the third generation, but there will be a switching temperature. So this is the switching temperature at which the heater switches to a lower output. In case of the third generation, as you know, it has a variable output. So it will also switch, but these switching temperatures, there'll be many. It'll basically be a small incremental change with every degree rise of temperature. So this over here, once the heater switches to a lower output, when it drops below the minimum, that's 167, the heater switches back to a high heat output. Because the first generation heater had only two heating outputs, it was very simple, whereas in case of the third generation, as you know, multiple steps. So it also has a minimum range. If it drops below the minimum temperature, basically minimum temperature of the coolant, the heater will also switch back to the higher outputs. So it can work both ways. It can go from a higher level to a lower level, or from a lower level to a higher level for the output of the heater. Now, if the temperature of the coolant were to exceed 185 degrees, this is kind of the threshold, then the heater will be switched off automatically. At that point in time, the fuel pump will deactivate, the heater will go through a cool down cycle and switch off. This cool down cycle that I just mentioned is important for the safety of the heater and its parts. The fuel pump switches off, the fan continues to run, the coolant pump continues to run. Usually the cool down cycle lasts for about somewhere between 2 to 3 minutes long. It is important though, because if you disrupt the whole process by, let's say, disconnecting the power supply to the heater, then the fan will suffer severe damage. And every time you do that, and then eventually it basically damages the fan completely. So this slide shows us the actual operation of the Hydronic S3 heater. Along the similar lines, it will also do a systems check initially. If it passes the test, then the coolant pump starts, goes through a set of preset sequences where the fan starts, the glow pin starts, the fuel pump is then eventually started supplying fuel to the heater. The glow pin will be switched off once the flame is detected. This heater, as I mentioned, will also make up to 2 start attempts. If the first attempt fails, it will make a second start attempt, but if both attempts fail, the heater will quit. And then once it finishes the cool down, once it's completely switched off, then it can be manually restarted. Now, depending on the heat requirements, the heat output will be constantly adjusted between the maximum and the minimum. So that's how this heater is different than the first generation. Okay, let's talk about diagnostics. So as far as diagnostics, we have two software available. The first one is called as Edith. Edith is an older version of our software. It's meant for all the older generations. You probably have it on your computers, and you probably have this tooling also. In the last class, someone did mention that you have this. Now, this is called as a universal adapter. This USB end of the adapter can plug into the computer, but because the other end plugs into the heater side, you would need an extension cord, a USB extension cord that will run all the way from this adapter to your computer. This way you can be standing beside the truck and not under the truck when you're doing diagnostics. What you see on the top right corner is the older version of this adapter. It's no longer available. I just put it there just in case if some of you have it in your shops. If not, you should be having the current version, which I mentioned as the universal adapter. Now, on this end, you will see a couple of connectors. So for the hydronic heater, you'll end up using this white connector with 4 pins, and this will basically match up to this adapter harness that you see, the Y harness. So this is the part numbers. So both of this would be required to connect to your first generation hydronic D5SC heater. Now, for the Easy Scan, that is another software. Now, by the way, the software are free. You can download them from our service portal. I will show you shortly how to gain access to the portal. But yes, you can always download the software from the portal at no charge. Now, you would need those connectors, as I mentioned. I'm going back to the previous slide. Yes, the adapters, the connectors, etc. All of this cabling will be required to be ordered in, but the software itself is free. Okay. Now, this, as I mentioned, the newer generation communicates with diagnostics over CAN bus. So these are CAN bus adapters. Here again, we have 2 versions. The one that you see on the top, this is the most current version. And then what you see at the bottom, that's an older version. This is being discontinued right now as we speak. Now, what's the difference between the two? The newest version will only work with the CAN bus version of the heater. So if it's a 3rd generation, yes. Whereas the older version also had a different protocol in it, which allowed it to communicate with older heaters like the Hydronic 1st generation. So if you did have something like this, or if you have something like this in the shop, then this can work with both the 1st generation heater and the 3rd generation heater. Whereas this style adapter for Easy Scan will only work with the 3rd generation heater. This does not require a separate Y harness. It will plug into this diagnostic harness. This is part of the harness on the heater on the truck side. So if you crawl underneath the truck, you will find this hanging in close proximity to the heater. It will be zip tied probably to the harness itself. And you can identify this with this yellow label, because under this yellow label is a 120 ohm terminating resistor. Now, if you do utilize this to connect to diagnostics, make sure that you don't bend or damage that resistor, because if you do, then it will not be able to communicate over CAN bus. All right. It has a cap on it, so you pull the cap off and then connect your adapter cable directly to it. Okay. So I have switched over to another screen here, and here you should see the website. If you want to download a manual or download the software, you have to first go on to our service website. So what you see over here is the address for the service website. It is service.eberspaecher.com. And once you enter that in, you'll end up with a screen like this. If you have registered already, you can proceed with the email address and password. Now, if you haven't registered, you have to go to the bottom and click on the sign up now link and then sign up for portal access. So this is important. I would recommend every technician should sign up. On the service page, you can then click on the link for Partner Portal. You will land on the next page, and this would be the Partner Portal page. Once you're on the Partner Portal page, you go up to where it says Dealer Area, click on Downloads, and once the download page opens up, all you have to do is pick and choose the selection from the menu. So for example, if you're looking for diagnostic tools, you'll click on the diagnostic tool link, and then you'll pick and choose which software you would like to download. So I'm going to click on Easy Scan, for example, and now it shows me the download link for the software. One key thing to note, the installation of that downloaded file should only be done by your IT admin who has full access rights to your computers. All right. And the same rule applies to the Edith software. So if I click on it, it'll give me the link for downloading the software. Now, the Edith software is the older version of the software, so it's no longer updated anymore because we are not producing new generation heaters that are compatible with it. Whereas Easy Scan is the latest, and it is compatible with all the newer generation. And it is always constantly updated. As you can see over here, the last update was on July 2025. So even if you did install the software, my recommendation would be to constantly check and see if an updated version is available, maybe once every 6 months or so. And if there is, please install the latest version. So over here, while you're on the portal page, you can also access technical manuals. For example, if I click on technical manuals, I can pick and choose the coolant heater link. Now I can pick and choose the heater type. So of course, that's the 3rd generation Hydronic S3 CS version. And if I click on that link, now I have all these manuals available for download. This is available 24/7. Okay. If you're looking for 1st generation heaters, then Hydronic 4.5 would be a link. Click on that, and again, you'll have all documentation and manuals available for download. So here we can see the 2 different adapters. So this is the cable that I was referring to in the previous slide. So you can see this is the CAN-only version of the adapter. It comes in 2 pieces. That's the part number right there. This is the older version. I have still put the part number because I believe we have a few in stock, but then once that gets over, it will no longer be available. The advantage of this is that you can connect this and you just use it over both the older version of the heater and the newer version. That's the advantage. Now, when it comes to the fault codes, yes, the newer generation, the memory capacity has increased. So we have up to 10 fault codes that can be stored in the storage memory. In the 1st generation, the heater could only store up to 5. So that's almost double the capacity. And also, in terms of the active codes, you could have 10 fault codes in the active fault memory in the newer generation heaters. Whereas in the older generation, you could only have 1 active code. Another important differentiation is that every code will have additional data. When I do a demo, I'll show you what that additional data looks like. This is only on the newer generation. It's not on the older generation. And in addition to all of this, the newer generation also has what's called as a mirror fault memory. And this mirror fault memory is something that you will not be able to see, but it can be accessed by a warranty. In case you have a warranty issue, you submit and they ask you for the parts and the ECU back, they'll be able to read out the fault memory, that is faults that are stored in the mirror fault memory. You'll also notice that the format for the codes are now different. It's a much more longer format. This is the automotive style format. So you have P followed by about 6 digits. In the older version of the heater, it was just a 2-digit format. So for example, code 10 would mean over voltage. Whereas in the new generation, we have the new style format. So these are the new style formats. Once again, although the format has changed, the description and the instructions to diagnose and repair the issue are very similar. Here we have code number 14 and 15. These are for overheating, for example. Code number 17 is for overheating. This is on the first generation. And if you look at very similar codes, you can see over here, these are the overheating codes. So we have P00115, for example, for overheating, 116 for overheating, etc. So the format has changed, but everything else is still kind of the same. Okay. All of this information is in the manuals. All of the entire list of codes, etc., is in the manuals. Another thing that you want to keep note of is the ECU locking out. So here we can see the ECU has lockout codes. The two different codes are P00012B as in Bravo, and then P00011A. These are the two lockout codes. So the heater ECU will lock out due to two events. And what are those two events? One event is your safety time exceeded. That means your heater tries to start, fails to start even after making two attempts, and then it ends up with an active code 12A. If this event were to repeat again and again 10 times, then your ECU locks out. It's not that you can sit there in the truck trying to start the heater as many times as you want. The maximum attempts you are allowed, or the driver would be allowed, is 10. All right. Now, that's not to suggest that the driver should be starting the heater 10 times, because each time you try and start the heater, and if it fails, you could have a lot of fuel that builds up in the heater and spill out. You'll saturate the heater, causing more issues. So you don't want to be starting the heater or restarting the heater more than twice. That would be the guideline. But from a safety point of view, it is the ECU locks out after 10 such attempts. The ECU also will lock out if there is overheating. As you know, the heater is in the truck. If you block the vents, etc., your heater will overheat. If there is a restriction in the coolant lines, it will overheat. And if such an event were to happen, then your ECU locks out with the code 11A. Now, you will need a diagnostic tool to unlock the heater. It's important. So if your ECU locks out, from that point onwards, you cannot operate the heater. To unlock the heater, the best way would be to use the Easy Scan diagnostic tool, and I'll demo it when I do a short demo now. I will show you how to unlock it. But another way would be to clear the codes, and that also would require the diagnostic tool. So without a diagnostic tool, you cannot unlock an ECU. And this is why it's important that at least a few select shops that mainly repair the heater should at least have this diagnostic tool in place. So when it comes to standard warranty, both the first generation and the third generation have the exact same warranties coverage. So you have the first 2 years in service, beginning from the in-service date, because these are factory installed heaters, or the first 2,000 hours in service, whichever comes first. So that's the scope for warranty. Very important to note that if you do have an issue with the heater, warranty doesn't cover for whole heater replacement. That means you cannot just pull the whole heater out and put a new one in and send the old one back for warranty. That doesn't work like that. Your claim will be rejected. Our warranty policy is basically an always repair policy. That means you should be diagnosing the problem, and then fixing the problem by replacing the required parts. That's basically how it's supposed to be done. Okay. So now, having said that, what about service and maintenance? Visual inspection of the heater at least once every year. So as you know, the heater is under the floor. It's exposed to the elements. You could have things flying off the road, hitting the parts like exhaust, intake tubing, etc., breaking it. So inspecting that heater once a year, preferably before the heating season begins, is always recommended. Another important recommendation is to operate the heater once every month, minimum 15 minutes. even during the summertime. Very important to test run the heater, even when you don't require heat. All right. Replacing the filter on the suction side of the fuel pump is another recommendation. Even though Freightliner does not use that fitting on the suction side, the pump assembly has a filter on that end that screws into that adapter, 45-degree or 35-degree adapter that Freightliner uses with the pump, with the standpipe. So remove the fuel pump and replace that filter. This is recommended. Now again, you may decide and say, all right, this is not required by us because we have not run into issues where the filter has been choked, and so that caused the heater to fail constantly. So we have never run into that problem. And you might say, okay, we will do it only when it fails. And we leave it up to the customer. Verification of controller settings. This doesn't apply to your application because your controller setting is basically just the push of a button. That's it. So there's no other settings there. And then finally, because we have a much larger capacity for codes, etc., it's always important to review the codes in the ECU. That way you get a true understanding of what kind of issues the heater may have been having, how many hours the unit has operated, and all of that good important stuff. So that is our recommended maintenance and service. We are going to do a brief demo on the EDIT software and the easy scan. So as you can see, we have the two shortcuts up on my desktop. So let's start with the EDIT software. You double click on it, you will see the EDIT logo appear. And then all you have to do is click on the shortcut here where it says select heater. Then go up to where it says heater type and then select your heater type. And your heater type should be the Hydronic B/D 4/5WSCS. So that's your group that you will select. And once you've done that, you can either do an automatic detection if you have a heater connected to your computer. In my case, I don't have one right now. So what I'm going to do is I'm going to scroll down this list and pick the right model number. This model number will be on the sticker that is fixed to the heater. Now, usually the heater comes with two such stickers. So if you have a new truck coming into your fleet with a heater, my recommendation would be to remove the secondary tag or the sticker on the heater and then place that sticker somewhere inside the truck, maybe inside the door panel, on the door jamb, so that you have access to it more easily and it doesn't get, wiped clean with the dust and dirt that may accumulate on that. So the model number typically for the first generation will be a 25, 23, 25. So let's locate that in this list over here, 252325. There we go. So we can see that's the one right there, but you'll see there are two of them. And you can see when I click on the one above, it only gives me two tests, a memory functional check. So that's an older version. Whereas the newest version with the same model number has got three different tests. The general data will give us an overview of the operating hours, the fault codes that are stored in the ECU. The switch on component will allow you to test individually the components like the fuel pump, the glow pin, the fan motor, the coolant pump. All of them can be switched on, off independently to test. So it's a very good way of isolating whether the component is at fault or not. And then the functional check is like an overview of the heater operation. It's a full comprehensive check. Now, whenever you do the test, the general data and functional check, both of these tests can be saved as a file, and then you can retrieve and play back that file at any later date in time. This file is also attached to your warranty claim, so that warranty is supplied with information as to what was going on with the heater and and why it was repaired. So you're providing proof that yes, there was a problem. So these two files can be saved and sent to warranty. So what I'm going to do now is I'm going to go ahead and open a stored version of both these files to show you exactly how the diagnostic files look like. So I'm just going to go over here and say data. So that is our general data test file. You'll see there are two windows that pop up when you're doing a test. Now, of course, because this is a recorded version, you're seeing the replay bar at the bottom. So ignore that for a minute. But and then assume that just make an assumption this is a live test. And you can see that it is showing us total hours of operation in hours and minutes. It is basically giving us a read of the overheating counter, the safety time counter. And then at the back, in the back panel, which you can access by simply clicking on the error button here, you will see all the codes listed. Because this is a first generation heater, we have only one active code slot or active codes, and then that slot right now reads a 0, that means no codes. And then in the 5 storage memory slots, you can see we have codes beginning with a 14 and all the way ending with a 51. And then we also have a small little description. So this way you're able to read out the codes, both the code itself and the description. Now, if you did have a lockout code, then what you would do is you would click on the delete button that will appear over here when you do a live test, and then that will clear out the codes. So if, in case of a first generation heater, if you do have an ECU lockout, then you have to clear the codes by simply clicking the delete button, and that way you can unlock the ECU. Now remember, unlocking the ECU does not fix the problem. Unlocking the ECU only allows you to test run the heater again, but you have to find out the root cause of the failure and fix it. Otherwise, the heater will fail again repeatedly and eventually lock out again. Now, when you're doing your test, it's advisable to save these test results, even if you're not submitting a warranty claim, because that way you can track any issues further down the road. So if you repaired or fixed a heater issue and the truck comes back, you can use these files to check what the status was on that unit before it left the shop after repairs. So this is a overview of the general data test. Very simple. You can always arrange these two windows, so that you can see both at the same time, or you can use these buttons to toggle between the two. Either way, your choice. So let's stop this playback and let's open another one. This is the function test. So in a function test, this is exactly what you'll get to see. You will see 3 panels, one which says measured values, next one says graphic, and then there's a third one which you really cannot see. That's the one for the fault codes. And these are the 3 buttons that allows you to toggle between each of those different panels. So in the first panel, you can see all the values. So that's why it says measured values. These are the values measured, whether it's for voltages, speeds, frequencies, temperatures, all of this will be shown. This is all shown in real time. And if you would like to see these values as a graph, all you would have to do is check the boxes besides the value and then click on the button graphic. The graphic view by default appears with a time span of 2 minutes. You can always extend that to 10 minutes or even 30 minutes. So that way you get to see a much more broader view. Because this is a recorded version, I can just scrub the timeline all the way towards the end. So it's a 24-minute file, and now you can see the entire graph from start to finish of the testing of the heater. So you are able to visually see the graph, or you can read out the measured values. And this helps you to check the operation of the heater, compare it with good known values, etc. You can also see, it also shows you the voltages, the battery voltages measured at the heater. So very useful tool. Okay, let's stop this test and we will exit this screen. And then the final chapter for the webinar is the Easy Scan. Very similar to your edits tool. It's a little bit more complex, much more refined. So if I'll click on Easy Scan, now you can see we can go and select, click on the select button here. We can select a heater type. So here, let me just back it up so that way. So we select water heater, 3rd generation, click on diagnostics, and then you select your heater, which is Hydronic S3 Economy Series 12 volt CS. That's the heater that you will select. And once you do that, you click on diagnostics. So you can see the diagnostic panel opens up. These are the different functions listed from right to left on the top. So for example, if you want to read the fault memory, click on fault memory. It will show you the fault memory that is stored in the heater. You can see we have an active fault memory showing we have a dosing pump or a fuel pump interruption, and this is because I have a heater connected to my computer, but it doesn't have a fuel pump. So it's showing us an active fault. But this is all under active failures. Remember, the maximum number of codes that can be stored over here is up to 10. 10 such codes can be stored. Now, if you click on the code here, you will see that we'll get further information about that code. And this is what I meant by additional data. And this applies to both active failure as well as stored failures. So if I click on stored failures, click on read, it'll read all the stored failures, and I can see all the stored failures also. Operating data shows us overall the operation of the heater, operating times, utilization profile, number of starts, loss of flame, counter values, etc. Right here in the middle is the safety time counter values. You can see the maximum threshold both for overheating and safety time. And this is the current value. So for example, if you have 10 overheatings, then that matches to the threshold 10, and then your ECU will be locked. In that case, all you have to do is press the reset button. If you press the reset button, this counter goes back to 0. And the same applies to safety time. This is the regular way of doing it because this way you do not clear the fault codes. You can also clear the fault codes and unlock the ECU, but the problem is when you clear the fault codes, all of this additional data is wiped clean. You can also do a measured values test. This is more like a comprehensive test, wherein you can go in and start the heater and visually monitor the operation of the heater. Check all the functions here. You can see all the values. Here again, if you would like to see them as a graph, you simply click on, whichever values you would like to see as a graph. And then when you start the measurement, basically you'll be able to see all the graph values appear on the screen right here. The component test tab basically allows you to do just that. So over here, you're able to go in and test run the components. So we have these tabs over here for internal components. So the motor, the glow pin, you can set the parameter range, you can set the time limits, and then test run the components, both internal components and external components like the fuel pump, the coolant pump, all of these can be tested. So as you can see, the Easy Scan is a much more versatile tool. Now, at the end of the day, when you're doing this diagnostic test, you can also create a workshop report. So if you click on report in the main menu, it'll show us a report that was created on the 20th. That's yesterday. But then you can go in over here and create a report. And then when you do that, your existing report will be overwritten. Now, ideally, you'll have to delete it, and then rather than override it. That's the recommendation. Right now, I'm not going to do this because I would need this file. So I'm going to save this file first, and then only then I can do it. But you get the idea. You have to delete the existing reports, go into diagnostics, click on workshop report, and create a brand new workshop report. That's the way it should be done. Okay. So I hope this brief overview about diagnostics is useful. We are done for this webinar session. Thank you so much for attending the webinar, and have a wonderful rest of the day. Thank you.